Hello, everybody. Hello, friends. I have a topic I would like to discuss a little bit about specific gravity and what does this mean in terms of soap making. Well, basically, when we make soap, we are using weight measurements. Everything is going to be weighed, and sometimes we are buying things that are sold in fluid ounces. And it can get confusing for people who are new to soap making that we might not understand what we're getting when we buy things that are sold in fluid ounces because we need things to be measured by weight. So, what I want to do today is just a little basic kitchen experiment. I'm not in the kitchen, but you can do this in your kitchen. And I'm going to do a demonstration and explain to you how you can better understand what you're getting in terms of, in the United States, we use ounces, but everywhere else, it's going to be grams and milliliters, and how you convert them when you're dealing with liquids. Okay, so this is a graduated cylinder. I'm going to start with a metric measurement, and then we're going to start with just water. So let me get you in here. I want you to be able to see I'm going to change my unit to grams and tear this. Okay. I'm going to just pour in, I have water. So one thing to keep in mind actually before I get started is that specific gravity is also dependent upon the temperature. So if my readings here aren't exactly what you would expect from the charts or whatever, it could be due to temperature or it could be actually due to the water. So you could have distilled water, spring water, any other kind of grade of water where it might vary slightly. Why is this doing this? Okay. Okay, stay 0. Okay, so, but it should be close, okay? And the idea should hold. So let me put about 50 grams of water. Oh, I got 55. Okay, so that's close enough. And then what I want to show you, and I hope that this will render. If not, you're just going to have to take my word for it. We have what looks like just about 55 milliliters of water in this. So what I'm trying to come across to you is that the milliliters and the grams are going to be the same with water, or close to the same, because the specific gravity of water is 1 or close to 1. So you can see, hopefully you can see my 50, down here is the 30, so this line would be 40, even though the 40 is not on there. It goes 30, 40, 50. Up here would be 60. You can see it's just about 55. It looks like a little bit more than 55, but in scientific measurements, we measure from the bottom of the meniscus, which I don't expect to be able you to see that in the video, but it's like the bowl shape that the water makes on the surface there. So you're supposed to read from the bottom. So it's just at about 55, close enough for me to be able to show you that the grams are equal to the milliliters. Okay, and so that is my water demonstration. Now, the same thing will hold true in the English system. And the problem with the English system that we use in America is that we use ounces as a measure of weight, and then we also use the same word, ounces, as a measure of fluid ounces, which is a measurement of volume. And that difference will lead a lot of people astray. You're going to wonder why. How come I went through so much essential oil? It's really expensive. I thought I bought 4 ounces and only got 3.5 out of the bottle, or whatever it was. It's because the oils are lighter than water. So Now really quick, I'm gonna change my unit to ounces, and the smallest one I have is 4 ounces. So I'm gonna show you the same concept in water, just with a regular measuring cup that you would have in your kitchen. Try to go to 4. I'm almost at 4, and you can see my measurement is 3.95, which is definitely close enough to give you the idea of what I'm talking about. So let me get rid of this water. Hello everyone in the chat. I'm just wiping out my container. Hold on. Okay. Now, so like I said earlier in the video, temperature plays a role in this, and also sometimes when you order oils from a supplier, sometimes you're going to get a certificate of analysis. It will tell you the exact specific gravity of the thing. And if your supplier doesn't give this to you, it's not that they're a bad supplier. It's probably because you ordered in small quantities. When you start to order in bulk, you get these certificates included with your orders. You can just look online and find a table of accepted values. It's going to be really close. So don't worry about that. But now I just got some olive oil. This just came from a grocery store. We're going to do 4 ounces of olive oil and see what we get. Now I looked up, because this came from a grocery store, it did not come with a specific value. So I found one, which is at 60 degrees Fahrenheit. The specific gravity should be 0.92. It's a little warmer in my room here. It's about 76 degrees Fahrenheit. So let me add about 4 ounces of olive oil. Oh, not there yet. A little bit more. A little bit more. Trying to be very careful. I don't want to overdo it. Okay, yeah, there we go. That's about 4 ounces. Let's see. I was using my phone calculator, but I'm using my phone to stream, so I overlooked the fact that I'm going to need a calculator. So I have some people watching. Will somebody pull out a calculator and tell me what is 4 times 0.92? And hopefully it's close to this number, 3.7. And then say in the chat when you have the answer. Anybody? 3.68. Thank you, Dino Hicks. I hope I pronounced your name properly. She says 3.68. Thank you for doing that little calculation for me. So you can see that 4 ounces of olive oil, we used the specific value, and we got 3.7, which is pretty close because my scale would round 3.68 up to 7 anyway. So that is a perfect example of how you're going to make these conversions. So the reason why this is so important is because I'm going to be weighing if I use this olive oil, and it comes with 51 fluid ounces. This is not sold to me by weight. This is sold to me by volume fluid ounce measurement. If I enter this into my inventory as 51 ounces by weight, I'm going to come up with a shortage later, and I'm not going to properly calculate how much my soap costs to make. So what you would need to do is you take this 51 fluid ounces and you multiply this by your specific gravity, and you will know the weight in ounces. Now with olive oil, it's not extremely expensive. It's not going to make a huge difference. But if you're using essential oils, it makes a big difference. So if you see one like this, sold in pounds, This one is sold by weight. Some companies are selling it by weight. That's great. I love it because that's how I need to input it into my program. I use the SoapMaker program because that's how I use it. But most companies are going to sell it to you like this. Hold on, let's focus. Fluid ounces, fluid ounces. So in that case, before I enter it into my inventory, if they provide a certificate of analysis, I use the specific gravity that they provided to me because it is specific to this batch. Like they will do a thing on just this batch. If they provide it, great. If not, I'll go online and I'll have to do a little bit of research to get an accepted value for specific gravity, and then I will convert the measurements myself into weight. So that is all that I have to say. Really quickly, I should say that specific gravity is relating to the density of the substance. In this case, we're talking about liquids. So that's what we're converting here. And so that was just a quick how-to demonstration on how to convert your specific gravity or to understand your specific gravity a little bit better. So I gotta get going now, but thanks for stopping by, and I hope that this video was helpful to you. Bye-bye.